Hello students, good morning. So let us continue our AC circuits. So in last classes we have seen basic terms regarding to electrical circuits, that is what do you mean with the node, loop, mesh, active elements, passive elements, and enhancement of problem solving with Ohm's law, and where Ohm's law unable to solve complex circuits, then we are going to adapt our Kirchhoffs laws. Last class we have also studied what do you mean by Kirchhoff current law and its application, and how to solve the problems by using KVL. Now in this class we are going to learn Kirchhoff voltage law. What do you mean by the definition of Kirchhoff voltage law? Applications of KVL for solving a different complex networks. Definition. What is the statement now? In any closed loop, the algebraic sum of voltage drops and EMFs equal to 0. What is the meaning? In a closed loop, for example, you take the one example. In closed loop, you take your own family. For example, your father and your mother both are employing, both are earning money, and you and yourself and your brother and your sister. Total number of persons in your small family is 5 members: your father, mother, your brother, your sister, and yourself. Let us assume your father earning 20,000 per month, your mother also earning 10,000 per month. So at the first week of every month they will bring amount from their office, 20,000 plus 10,000, total 30,000 at first week of every month as a salary. They are earning. Let us assume they are the active elements. Active elements, sources, money sources. Now whereas your brother, yourself and your sister is studying in different levels. Now your brother is studying engineering, you are studying polytechnic, and your sister is studying school level. So your parents has to pay daily whatever the amount is required to livelihood, they have to take from their salary. But your brother, your sister, yourself not earning any money, but whatever the amount is collected by your parents, you are consuming. Your school books cost, your school fees, and your dresses, everything, food and cloth, everything, basic needs, that is given by your parents. Now your three kids are consuming whatever the amount is generated by your parents. They are the sources, you are the loads. in a closed small house, in your small house, your house is nothing but closed one, and your father is, for example, one voltage source, your mother is also another voltage source, your brother and your sister and yourself connected in series in a closed circuit. Now whatever the source amount is generated by voltage sources, your father and mother, that is consumed your brother and sister and yourself for your education purpose. You are consuming, your brother is consuming, and your sister is consuming. Let us assume this consumption of amount, let us assume drops. What do you mean the drop? Voltage drop. That is equal current into resistance. IR drop. Your brother acts as a one IR drop. Your brother has a R1 through which the current is flowing, same current, I into R1 drop, voltage drop. And same yourself is the R2 resistance, then current I into R2 is the another drop, and your sister is the R3, same current, the I into R3 is the another drop. Your brother one of the drop, yourself one drop, and your sister is one drop. 3 drops is equal to amount, whatever the amount is generated by your father and sister is equal to 0 for a 1 month. Let us assume 1 month. In 1 month, at the first date of 1 month, they will bring the salary. At the 30 of end of the month is completed. That means sources coming and consumption. No saving at all. Similarly, same is applicable in our KVL. In closed circuit, your house, voltage sources, your father and mother, drops, IR drops, yourself, your brother and sister, and finally the equal to 0. Whatever the amount is stored at the end of the month is equal to 0, because next month once again they will bring the as a salary. No need to save. Whatever the amount is taken by 30,000, you are consuming 30,000 at the end of the day. Here also same thing. Algebraic sum of EMFs plus IR drops. You can see this one. So in here the sum of EMFs, your father and mother, drops, your brother, sister and yourself, equal to 0. That is, what is the amount saved in month? 0. You are not saving. Whatever the amount is coming, so that is totally taken out. Okay. Now similar analysis in your whatever the your house is equal in closed circuit. This is a closed circuit. And whatever your father and mother earning amount are, for example, here the one source, sometimes there is another source. For example, only your father is doing employee work, and your mother, your brother and your sister not working any work. So what do you mean? So your father, whatever the salary, that is equal to voltage source, and whereas yourself, your brother, your sister and your mother depend on this source. At the end of month, this whatever the salary is equal to 0, no savings. Here similar assumption. So whatever the source Vs, sum of the Vs, here only one EMF source, active source. Now here the current is flowing I into R1, this is the one drop, same current I into R2, another drop. So here, so we can write it. So Vs is equal to I into R1 plus I into R2. So whatever the sources equal to drops, or we can write it Vs minus I into R1 minus I into R2 equal to 0. Same formula we are applied here. Kirchhoff voltage law. Once again, what is the definition? In any closed loop, there should be closed loop, not only your family, not side by your brother, cousin or uncle family. So in a closed loop, the algebraic sum of voltage drops, this drops is equal to, and EMF equal to this EMF. That is the definition. Now you can see here, Kirchhoff laws can be applied in a complex circuits to solve unknown currents and voltage drops any one circuit as per our requirement. So before going to do that analysis, you should remember the current direction in a resistor, that is a drop, the current I into R, the current which is flowing from which direction. In a closed loop, whether your loop is nothing but, you can see, don't confuse one thing, you have to remember the plus or minus, the sign indication while doing the calculations. Yes, simple. So sign conversion. In case of resistors on the electrical network, the assignment is given as follow. That is a sign assignment. What is the sign assignment? The current direction in that resistor and loop direction of the current both are in the same direction. The voltage drop is assigned with a negative. That means, for example, you take the one example here. Suppose this is a closed loop. This is the one source, for example, you can take it here. This is a source. Okay. Now here resistance is connected. Now here resistance is connected. And now here connected. Plus minus. Now I am considering the closed loop. This loop is a closed loop from this place. So let us take another color, and this is a A, this is a B, this is a C, this is the same, that is a C also, D, for example take. Now I am considering AB, BC, CD and DA in a closed loop. Now here voltage source is the this one, and drops are the R1, drops are R2, these are the drops. Now here I am considering loop from A, B, C, D. This is the A, B, C, D closed loop, this direction. Now what is happened? For example, before assuming the closed loop, you have to remember that the direction of the current in a resistor. So how we are going to find? So because the positive, the current is coming this direction and entering, and this we taken as this direction. This is a positive, this is a negative. High potential to low potential, dropping. Now same current is entering here, plus this is a minus. Current is coming this direction. And this is also this is a negative. The current direction is this direction entering here. So this is the plus minus indications. Now we assumed a circuit ABCD or ADCB, whether which direction you are going to assume it. Which direction you are going to assume it. So you are going to that take it. Now in this case I assumed A, B, C, D. That means in this direction. Suppose I can take A, D, C, B, this direction. I can take. So my intention, I can take clockwise direction or anti-clockwise direction. Whatever the direction you take it, you are going to get the same values. But the sign, instead of minus value, you may get. So that indicates that if the positive value comes after simplification of the problem, your assumption is the correct assumption. If the value comes negative, your assumption is reversed. Simple. That means whatever you are assumed, in this case I am assumed first case clockwise direction, I am going to get the current in the circuit with the 5 amperes. Suppose I am going to assume in the anti-clockwise direction. So anti-clockwise direction, then A, B, C, D, then I am going to get the current I is equal minus 5 amperes. That means, so what I have assumed in anti-clockwise direction is not correct. So you change into positive, that is the clockwise direction. That is enough. So initially we don't know which direction the current is flowing. So arbitrarily you take the direction. Based on the direction you go ahead do the calculations. It is not wrong. You do it. That finally you are going to get the final values whether it is a positive or negative. If it comes positive, so your assumptions are well and good. Otherwise your assumption is some places there may be changes. You have to change the direction of the current flowing through the resistors or loads. That is a thing you have to remember. Okay. Now in this case what we are going to assume here, so what they are saying here, loop current, this is a loop current. Here you can see this is a loop current. This current is flowing this direction. At the same time the current is also flowing same direction. So the current flowing in the resistor is this direction, and loop also you can see it, loop also flowing this direction. That means this direction. Both are this direction. Current in the resistor and assumption also same direction. So we have to take it value. For example, this is a R. So I am take the, what is the drop? Drop is equal to I into R. But so the current direction and loop direction the same. I have to take the, instead of IR minus IR you have to take it. That is enough. Once again I am going to explain is, please listen. First indicate the current flowing through the resistor based on the voltage sources, which is the positive, which is the negative. Based on the voltage intensity, you have to assume the current flowing through the resistors. Just arbitrarily indicate it. Then after completion of plus minus values in a closed circuit, then assume the loop in one direction. Then based on this one, the current which is flowing in the resistor, that is the one thing, and your, for simplification purpose, you are assumed the loop whether it is a clockwise direction and anti-clockwise direction. The assumed clockwise direction current and current in the resistor are both are in same direction, then that value drop should be taken as a negative. If current flowing in the resistor one direction and the assumed loop direction is a opposite direction, the both arrows are reverse, then you have to take it the positive value. This is a thing. Okay. Now, so based on here I am going to take, so V is equal, drop is equal to minus I into R, because the current in the resistor and assumption loop also same direction. So I take in the V is equal to minus I into R. Okay. Now loop direction of current, this is one. Now current direction of the resistor and loop current are in opposite direction, already we have seen. Both are positive. Now this direction is going, we can see here, the current is flowing in the resistor this direction, but loop direction is this direction, the anti-clockwise direction. Both, this is this direction, this is this direction. You have to take the value. So V is, so drop is equal to plus I into R, because opposite directions. Okay. Now in case of EMF sources, now we have seen the voltage sources, the drops. Now you can see the voltage direction in the sources at the time, at the point of sources. In case of EMF sources are there in a given network, the sign assignment is given as follows. The current direction in an EMF source is from negative terminal to positive terminal. The voltage drop is assigned as a positive. That means here you can see it. This is the, for example, this is a positive, this is a negative. As we know that plus minus. If the loop direction you are assuming this direction, anti-clockwise direction, negative to positive, then finally we are going to positive. That is the voltage is rising, low voltage to high voltage, voltage is rising. At that condition, you have to take this voltage is equal plus V1. Or suppose if you have taken this direction, loop direction, this direction. Now what will happen? It is coming the positive to negative. That is a positive to negative, it's a drop. Voltage high potential to low potential. So we are going to drop. So you take the minus V1. That is the difference between voltage sources, this source. We know that this voltage sources generating its current direction from the terminals, positive terminal, negative terminal. So simply generally we are assuming the positive terminal, the current is leaving and entering in the negative terminal. So based on our assumption, we are going to do the similar assumption, total problem you have to apply it. Okay. Now example, same thing. You can see here example. What is the example? Here the current is entering, this I1 is the opposite direction, negative to positive. Then you have to take raise the voltage, low voltage to high voltage. You take the voltage drop, that is called plus V. Here plus, or you can take the plus E. This is a drop. Okay. Now if reversed, the current direction in an EMF source is from positive terminal to negative terminal, the voltage drop is assigned with a negative, similar to the previous one. Now in this case you can see it. Here this is a positive terminal, this is a negative terminal. The current is flowing this direction. So high potential to low potential, you have to take that the voltage E, this is equal minus E. That's enough. Okay. So these are the four assumptions you have to remember. One is the current flowing in the load resistor, current and loop current are both direction. You have to take the drop as a negative value. If the current in the resistor and assumption direction, loop assumption is the opposite direction, you have to take the drop as a positive. And in case of the voltage sources, the current, loop current is going from positive terminal to negative terminal direction. The voltage high potential to low potential, we are going to assuming that voltage drop. And suppose the assumption is a reverse, the minus value to positive value, low potential to high potential value. The assumption loop direction is a minus to plus to the voltage raise. You have to take the plus E. There are four assumptions you have to assume. If otherwise what will happen? If you want to assume the reverse, nothing problem. But same you have to keep the consistency overall the problem. These are the assumptions. You can assume any at a time, but it should be consistent. It should be follow the overall problem. So whatever the value finally you are going to get is the positive values, then your assumptions are perfect. If getting the minus value, any one of that value, that assumption is not that direction, you have to change the direction. That is enough. Now you can see the one problem. From the KVL statement, the algebraic sum of given loop is as follows. So here you can see this is a one voltage source, this is the another voltage source, your father, your mother. Okay. Now this is your small family. Small family. This is a closed loop. Now here is a your brother, here is your sister, here is yourself, and here is another brother. For example, a 4 children in a family. Now this is the drop. So you require the amount for study purpose. You require also amount is required. Your sister also amount is required. Your elder brother also a required amount. So whatever your father, your mother earned amount is equal to consumption of amount for your studies purpose. Month ending, whatever the sources is generated, that is ended at the end of the month. The money in your house is equal 0. Same thing you are going to analysis here. Now in closed loop, so here the loop current, you can see this is the loop current. We taken the loop A to B, B to C, C to D, and D to A. We are assumed. Now in this case, just I assumed the current direction in resistors is given. Now R1, the current is flowing this direction. Okay. Now here the E1 source, the E2 and E1, your mother, the current direction is a positive direction to, it is a leaving, and negative direction is entering here. Okay. That means in the branch the current is flowing from C to B. But whereas in loop current, you can see this assumption is this direction. Okay. So that is the plus minus here. Now here plus minus, just assume it. Here the enter is a leaving, the current direction enter is a plus, this is a leaving minus. Is a plus, entering is a plus, leaving is a minus. Just you assume that. Current entering is a positive and leaving is a negative. Here the current entering this direction, you take this a positive and this is a negative. Here the current is entering here, you can see it, so positive, negative. If the current entering here, you can see it positive and negative. Okay. Now based on these assumptions, you can observe that this one R1, the resistance, the current in the resistor is this direction, and assumption loop direction is this direction. So you have to take this drop should be negative. Now in this case, you can take it voltage you are taking, so current direction in this direction and current direction in this direction, the opposite direction. You have to take this as a positive. Now in this case, you are taking the current direction this direction, this is this direction, opposite directions, you have to take the positive value. Now in this direction, the current direction and this direction, the same direction, you have to take the drop as a negative value. Now in this case, the current is flowing this direction, loop direction, and current is this direction, opposite direction. You have to take this drop as a positive. Please see once again. The current here, the current is flowing this direction and loop current is flowing the same direction. This drop should be taken as a negative. Here the current direction is this direction, it is going opposite direction, this direction, and this is this direction, opposite direction. This voltage source you will take the plus E1. Now in this direction, current is coming this direction. So current this direction, loop is this direction, opposite direction. You take it, this is a positive drop. Now here the current direction and this direction both are similar direction. No, this drop taken as a negative value. And the current direction is this direction and loop direction is going this direction. This is a closed loop. And opposite direction, you take this drop as a positive. Okay. So assume these values, simply write the equations. What are the equations? From A to B, consider the loop. What is the loop? Here I am going to take the loop that is equal to A to B. What is a drop? Only one drop is taking place. That is equal to, both are same, minus I1. So you take the current is the same. You can take the I1 or I1 into R1 drop. Next, B to C. Now plus. So both are opposite direction. So E1. Next, it is going to, this is the, both are opposite direction, plus what is the value? So that is equal to I1 into R2. Next, you are going to this direction, minus, both are same direction, minus I into I1 into R3. Now it is going in this direction, opposite direction, plus, so I4 into R4. Next is coming to the end position. Next here is the plus to minus. The current direction is also this direction, coming in this direction and going the direction. So you take the, that is also plus to minus, you take the opposite directions. So plus E2 is equal 0. So you can write the simple equations. Now you can see it. From A to B, here from A terminal to B terminal. So A to B minus I1 R1, both are same directions. In B to C, this direction, there is two elements, one active element and another passive element. Now we taken, so here what is happened? Both in opposite direction. This is coming this direction, loop direction, but the current is flowing this direction. Both are taken the positive values. Now in this loop C to D, this loop, so both currents are in same direction. So we take as a negative value. In this case, the current direction this one and it is going this direction. So opposite direction. So we have take the both are positive values. Then write the equation as per the KVL. AB plus BC plus CD plus DA. We are going to close the loop. Then we are going to is equal 0. So here what is the your drop, your drop, your drop, your drop, your father and your mother sources. All are equal to 0. So by simplifying this equation, we are going to get that E1 plus E2, your father and mother salary equal to your charges, your brother charges, your sister charges and your younger brother charges. So that is the equation. Okay, so that is the E1 plus E2 is equal I1 R1 minus I2 R2 plus I3 R3 minus I4 R4. These are the closed loop equations, KVL, in a one closed loop. If a circuit may be consist of the number of loops, write the each equation. So this is a one equation. And consider the another loop. Here may be another resistance and another source and another resistance here. So this is another loop. You are going to get the another equation number 2. It may be another equation here, equation number 3. So we are going to get equation 1, equation 2, equation 3 for finding the unknown values of 3. Okay, so the I1 current, for example, this is the I2 current. So loop currents, unknown values we can easily calculate it. Now, so what we have seen in this class, so just you practice it, problems, you are going to get the values. Instead of here, what is the value? So what is the formula we are going to get? So this is the formula. So instead of you take the R1 is equal, for example, you taken R1 is equal to 2 value and R3 is equal to 3 value, R4 is equal to 4 value and R1 or R2 value is equal to, okay, R1 value is equal to 1, R2 is equal to R3 is equal to 3, R4 is equal to 4. Simply substitute these values in the equation. So here voltage, for example, E1 is equal to 12 volts and E2 is equal to 10 volts. Then what is the E1? 12 volts plus 10 volts is equal to, so I don't know I can take the I is a common into, what is the R1? 1 minus 2 plus 3 minus 4. So this is the equation. So here known value, known value, known value. Only I is a unknown value. What is the value? Here that is equal to 22 is equal to, so 1 minus here, what is the positive values? 1 plus 3, 4, 4 get cancelled, minus 2. So we are going to minus I into 2I. So I want the I. So I is equal to, I can write it, I is equal to 22 by minus 2. 2 ones are 2 11s are. That is equal, I get it, the current is equal minus 11 amperes. That means whatever the assumption I taken in the loop, this clockwise direction is not clockwise direction, you have to take the anti-clockwise direction. That is a simple. That means what is the current in the flowing? Current is equal to, this is equal, for example, this is the I current, this is the I current, this is the I current, this is the I current. So you assume that we are going to get that 11 amperes. But in our circuit is given the different. This is what is the current here again? This is the I1 is given, and here is the I2 is given, here is the I3 is given, this is the I4 is given. So to solve this equation we require the 4 equations. So adjacent to the another combination of equation we are going to calculate. So now previously we calculated, this is a simple loop where same current, I current is the same current is flowing through the circuit. We assumed the some resistance. Based on this we are going to calculate it. The current is coming, we have taken the loop this direction. So I is equal, we have got it, that is equal minus 11 amperes. But actually, so your assumption is somewhat reverse. So I is equal to 11 amperes. That means you have to indicate that the loop is this direction. That is enough. Instead of you taking the A, B, C, D, you take the A, D, C, B, you take it. That is the changes. Just you change it, you are going to get the same values. If required, you do the problem, you are going to get the same positive value. By assuming the current direction instead of clockwise direction, you assume the anti-clockwise direction. Do the same problem, you are going to get that instead of minus 11 amperes, you are going to get the plus 11 amps. Okay. Similarly, these problems you can do the remaining problems, simple equations, but you require the practice. Better to practice these problems in BL3 value 1, simple circuits. At least you have to practice minimum of 20 problems on KCL and KVL. Then you are going to get the master on the circuit. This is basic circuits. If you know the basics, you are going to easily understand the power system analysis, machines analysis, and different networks also. So these are basic things, and don't neglect it. You do the more number of problems. Okay, so let us summarize what we have seen in this class. So in this class we have discussed about the algebraic sum of product of current and resistance plus EMF is equal to 0. That is the definition of the KVL, and that is equal IR drops is equal to EMF is equal to 0, and KVL is applicable in closed paths and meshes only, and the current direction in the resistor and the loop current are both are in the same direction. The voltage drop is assigned with a negative value, and the current direction of resistor and loop current both are in opposite. The voltage drop is assigned with positive value, and based on simple calculations you may master in the networks. So Thank you for listening this class, a quiz and mostly frequent questions. You can do the problems.